We now discuss the solution of a problem from the section Matrices and Determinants, and the problem is on adjoint of a matrix. This question has appeared in Joint Entrance Examination Main held on 24th June 2022 in the shift 1. The problem is, let S is equal to the set of all root of n, where 1 less than or equal to n less than or equal to 50 and n is odd. Let A belongs to S and A is a 3 by 3 matrix whose first row is 1 0 A and second row minus 1 1 0 and the third row minus A 0 1. If sigma A belongs to S of determinant of adjoint of A is equal to 100 times lambda, then lambda is equal to, we are given 4 options. Option 1, option A 218, option B 221, option C 663, option D 1717. We are given a set S consists of root of n, where 1 less than or equal to n less than or equal to 50, where n is odd, and A belongs to S, and we are given a 3 by 3 matrix A whose first row is 1 0 A, where A belongs to S, second row is minus 1 1 0, third row is minus A 0 1, and if sigma of determinant of adjoint of A, where the summation runs over all A belongs to S, that is equal to 100 times lambda, we have to find the value of lambda from these given 4 options. We will now discuss the solution of the problem in detail. That is the given problem to us. Solution. We have S is the set of all root of n such that 1 less than or equal to n less than or equal to 50. That means n takes values 1, 2, 3 up to 50, where n is odd. So that means n takes the values 1, 3, 5, 7, etc. up to 49. That means this is equal to under the square root of 1, square root of 3, square root of 5, etc. square root of 49. These are all odd, and the last odd number is before 50, that is 49. And this is the set of all those under the square root of 2n minus 1, where n is equal to 1 to 25. Obviously, S has 25 elements. The order of S is 25. Okay, we continue in the next slide. So, we have this S is equal to the set of all under the square root of 2n minus 1, where n takes values 1, 2, 3 up to 25, and therefore S has 25 elements. Given A is this 3 by 3 matrix, and where this A belongs to S. That means for each A belongs to S, a 3 by 3 matrix is given. That means we will, and how many A's are there? 25 A's are there in S. So therefore 25 matrices will get. And now sigma determinant of adjoint of A, where the sigma runs over all A belongs to S, is equal to 100 times lambda, and we have the result, that is, let A be a square matrix of order n, then we have determinant of adjoint of A is equal to determinant of A to the power of n minus 1 when A is non-singular. So this is the formula. Determinant of adjoint of A is equal to determinant of A to the power of n minus 1 when A is a square matrix of order n and A is a singular matrix. So in our case, this implies sigma, where the sigma runs over all A belongs to S, of determinant of adjoint of A is determinant of A to the power of n minus 1 where n is 3. So determinant of A to the power of 3 minus 1 is equal to 100 times lambda. That is sigma A belongs to S of determinant of A square is equal to 100 times lambda, where the determinant of this matrix, the determinant of 1 0 A first row, minus 1 1 0 second row, minus A 0 1, expand by means of the first row, we'll get 1 times 1 and 0, leave it, and A times plus A. So A times A is A square. That means we will get 1 plus A square. So the determinant of A is 1 plus A square. Substitute here. We continue in the next slide. So that is the one, and the determinant we have calculated 1 plus A square. Substitute here. That is sigma A belongs to S. Determinant of A square, that is 1 plus A square whole square is equal to 100 times lambda, where S is under the square root of 2n minus 1 for n values 1, 2, 3 up to 25. So now this will be sigma 1 plus A square whole square. What is A square? A belongs to S. A belongs to S means A is under the square root of 2n minus 1. A square is under the square root of 2n minus 1 square. This is A square. And now the sigma runs from n is equal to 1 to 25 because n takes values 1 to 25. So sigma A belongs to S now converts into sigma n is equal to 1 to 25. 1 plus A square is under the square root of 2n minus 1 whole square is equal to 100 lambda. So that is equal to that implies sigma n is equal to 1 to 25. 1 plus, if you square it, then you will get 2n minus 1 and the whole square. Minus 1 plus 1 cancels. 2n whole square is 4n square. So 4 times sigma n is equal to 1 to 25 of n square 100 lambda. That is the sums of squares of the first 25 natural numbers. And we have the formula n into n plus 1 into 2n plus 1 by 6. And that is equal to 4 into n, 25 into n plus 1, 25 plus 1 into 2n plus 1, 2 into 25 plus 1 by 6 is equal to 100 lambda. That is 4 into 25 into, this is 26, this is 51 into 51 by 6 is equal to 100 times lambda. So where lambda, now the value of lambda will be 4 into 25 into 26 into 51 by 6, and in the denominator 100. In the denominator 100. So cancellations take place and we will get 13 into 17, that is 221. So the lambda value is 221. So we have these 4 options here, and our answer 221 appears again as the option B. Therefore our answer is option B. So that is a simple problem from the matrices and determinants, and the problem is based on adjoint of a matrix. I am sure that you have understood the solution of this problem, and go on working out similar problems from the section matrices and determinant. I wish you all the best. Thank you.